first of all, thank you, Marie, for that great introduction. And thank you for the invitation to come here and speak to you all today about my career pathway, which, not unlike some of the ladies that we heard this morning, has not been the traditional career pathway. And it's been a rather long and winding road, but in the end it was very worthwhile, and I've gotten to do a lot of very interesting things, which most people who, when they think of a scientist, would not have expected that that would be something you might experience. And so I'm going to tell you a little bit today about, as Marie said, a lot of things. And hopefully answer some of your questions with regards to obstacles that you may have to overcome, or interesting career pathway choices and things like that. So it's also very great to be back on the Auburn campus, and as I said, we were driving in yesterday. I haven't been back here in probably about 4 years or so, and I didn't recognize it. I thought I was in the wrong town. So there are so many new buildings and new restaurants and hotels, and it's mind-boggling. So it's great to be back and to be among some friends and see how things are changing here at Auburn. So anyway, the title of my talk is Non-Traditional Journey in Science, but the real title is how to do what you love and see the world at the same time, and hopefully get someone else to pay for it. So, for those of you who don't know where UMBC is, it is in Maryland, outside of Baltimore. If you've ever flown into BWI Airport, it's about 2 miles away. And I live down in Washington, D.C., because, as Marie mentioned, I'm married to somebody at NIH, and that's down closer to Bethesda. But I've also spent a little bit of time, as you're going to hear throughout this talk, in Washington, D.C. for the last couple years, doing some very interesting things that sort of arose out of a very chance meeting back in 2002. And so here you can see where UMBC is located. That's University of Maryland, Baltimore County. University of Maryland College Park is down much closer to Washington, D.C. This is about 30 miles away from Washington. And then in downtown Baltimore, we have the medical school, University of Baltimore. And so someone asked me this morning what the C stood for. It's Baltimore County. That's what designates us differently. And we are the honors campus for the University of Maryland system. So, and here you can see some of the buildings at UMBC. The library and the chemistry building is on the bottom. And we have a very nice campus. It's about 42 years old. And we enjoy the proximity to Washington, D.C., as well as the Inner Harbor of Baltimore, where many of my students go to hang out. And also, we have our choice of 2 baseball teams to root for as well. So, which in my group is very important, so we like sports. And before I talk a little bit about where I came from and how I got there, I just wanted to give you a brief overview of our research. We work in the area of drug design, and we try to design compounds to work against cancer, viruses, parasites, and bacteria. And one of the biggest problems facing medicinal chemists today is the development of drug resistance. And so one of our challenges that we've been working on for the last few years is to try to design drugs that can overcome these problems with drug resistance. And so a couple years back, we sort of introduced an idea that was very, very radical, because in drug design theory, for many years it has been thought that you had to have a rigid drug in order to have biological activity. And what we proposed was that instead, that flexibility would be a much more advantageous property for the drug, because it could allow it to overcome mutations in a binding site of an enzyme that's required for replication of various diseases. And everyone thought we were crazy. And then in about 2004, there was a report for etravirine and tenofovir that they were able to overcome viral resistance mechanisms in reverse transcriptase for AIDS because of the fact that, as they put it, they could wiggle and jiggle. So because they could move around in the binding site, which a rigid analog could not do. The other mechanism by which drug resistance develops, besides the mutations in the binding site, is the overproduction of target enzyme. And this occurs because we have to give the drug so often. And so these viruses are very smart. They want to survive. It's like cockroaches. Viruses and cockroaches are going to live forever. And the idea was to, if these drugs could be flexible, they can change their conformation based on what they encounter in the binding site. And so maybe they would appear as if they were a different drug to the enzyme, and then they would be able to overcome that mechanism as well. And so we introduced these some time back, and you can see them on there. And we like to call them molecular chameleons, because like the chameleon, they can adjust their outlook, what they look like to the rest of the world, based on the environment that they encounter. Some of the other areas that we have work in is looking at DNA structure and function. That's a much more fundamental project, but for the most part, all of the research projects in my laboratory involve drug design and development, and my graduate students work on all sorts of very interesting problems. And we make a lot of different compounds. We also make a lot of road tar, but hey, that's drug design, and I'm sure Dean Schneller's group understands that very well, so, or they will as they go along. Now, what I'd like to do today is really to tell you about the pathway that got me to this point. And it's been a very interesting journey. And I guess you could say it all started back when I was in high school. I was part of a program that was very unique at the time. It was sort of the introduction of the AP system and the baccalaureate, International Baccalaureate program, where they allowed you to attend high school as well as college at the same time. And so by the time I finished high school, I started college when I was 15, technically, and by the time I finished, fortunately I was able to graduate with my high school class, which was nice because it didn't really disrupt you and you weren't quite as much of a geek as you could be. And one of the things that really got me started was that I wanted to be a veterinarian, just like Jennifer said this morning. I grew up around many animals. I still have many animals. We have a zoo at our house, basically, and I wanted to do research in genetics. And so the project that I started on when I was in high school involved taking 2 dime store mice, because in those days you could actually buy mice in the dime store. Actually, I don't know what you can buy for a dime anymore. So maybe a piece of bubble gum, maybe, I don't know. And so I took 2 random spotted mice and I bred them to create a pure black mouse. And it took about 16 generations, and to the consternation of my parents, who weren't real keen on the about 15 cages and aquariums I had all over my bedroom that smelled really bad for about 1.5 years, and my cat sitting at the bottom of the stairs, because I was up, they put me in the 3rd floor. I can't imagine why, you know, and shut the door. And my cat would sit at the bottom of the stairs howling because he was convinced that these were lunch, you know. And so it was a very interesting project, and it really started my interest in science. And believe it or not, when I went to college, after I left, when I went to real college, it never occurred to me to choose chemistry. I never thought that I would be anything other than somebody working in genetics in veterinary medicine. And then somewhere along the line, well, in the meantime, I guess I should go on to the timeline. As you can see here, I was going to high school and college at the same time. Then when I finished that, I started at Penn State University, and I got married in 1977, dropped out of school. Then about 5 years later, had my first daughter, and in between the births of my 2 daughters, I went back to school at SPJC, got an associate's degree, and then my second daughter was born. then I went back to school again at USF, and my husband had a business, and he needed help in the business, so I dropped out again. And then I came back again and got my undergraduate degree, and which, as you see, finally, it took a long time. And then I had started with Dean Schneller before he moved here to Auburn, and I moved with him to finish up my PhD because I was only about a year away from being done. Unfortunately, along the way, I ended up divorced from my first husband, and I stayed on here as a postdoc at Auburn for Stu, and worked on his research for some time. And then about that time, I turned 40 and said, you know, I think I got to get a real job one of these days. So I very tentatively put out some applications and applied to Georgia Tech. And next thing I knew, I was an assistant professor at Georgia Tech. And my daughter and I was a single parent at that time, just like Carmen was telling us about this morning. So I understand the challenges, trust me. It's very difficult. And one of the things that was interesting about choosing Georgia Tech was that they had never tenured a woman in chemistry. And I went there knowing this, but I'm pretty stubborn. And I said, that's it, I'm going to be the first one to get tenure. And at the time, there was one woman in the department of about 40 faculty, one woman. And in fact, in the College of Science at Georgia Tech, at the time, there were 8 departments, and from those 8 departments, one of which had almost 100 faculty members, there were only 11 women, and only 3 of them had tenure. And so I knew I had an uphill battle, and let me tell you, I could tell you stories, but we'd be here all day. So it was a very interesting challenge, but I'm a firm believer that if you really want something, you'll go for it, no matter how hard. And there were days, trust me, it's 2 o'clock in the morning and I'm trying to clean the bathroom floor and do the laundry, and because of course I still had all of those things to do. My male colleagues had wives or didn't care if they were single, they just let their apartments get dirty, I guess, I don't know. But I still had to help with the homework and deliver somebody to golf practice and try to raise a teenage daughter who at the time couldn't drive. So that sort of made the challenge even harder. And trying to get tenure is very difficult, especially at some place like Georgia Tech. And you have to work night and day and, pretty much 24/7. And so it was very, very hard learning how to juggle. But as many of the ladies said this morning, you have to learn how to multitask. And I think that's one thing as women. No offense, guys, but we definitely outshine you on that. And so multitask, well, with the exception of maybe Dean Schneller, because he's pretty much, he's much better multitasker than anybody I know. So, but anyway, so as time went on, I worked very hard at Georgia Tech, and then in about 2000, I guess it was about 2000, several things happened. One, a group of Russian scientists came to Georgia Tech as part of some sort of symposium or something that they were doing. I'm not exactly sure. But I was asked to give a brief talk to them and show them my laboratory, talk to them about my research. And so there's these 40 scientists. And of course, doing drug design, it's something that everybody understands. And where some of my colleagues who were doing much more theoretical work, it's not as easy to sort of show this to the public. And so I was often doing these kinds of little talks and things like that. And I didn't really give it a second thought. And at the end of it, one of the Americans that was accompanying them said, "Would you be interested in working on a project in Russia?" And I thought, oh, cool. So, and I should say at this point that as of 2002, I had never been out of the country. And in 2002, I was 42, I think, something like that. And I had never left the country. And so the idea of going to Russia seemed really neat. And so I said, sure, no problem. And over the next year and a half, they worked through the details, because unfortunately there were a lot of details involved with these particular projects. These focused on the smallpox projects in Russia and working with former bioweapons scientists and trying to help keep former weapons scientists from, not having anything to do and maybe selling their stuff to the wrong people. And so we've worked very hard with these scientists, and also doing collaborative research with Russia because of the fact that there are bad people out there with these bugs, and we need to be able to combat them if an outbreak should occur. So anyway, at that particular point in time, I made my first trip to Russia in 2002, and when I came back, I also had study section at NIH. And this was my first opportunity to go to NIH to study, to work on a study section and do review. And believe it or not, this study section person ended up being my husband. I didn't get funded, but I did end up did get a marriage proposal, and so it was very interesting. And actually, the slides out of order here. But one of the people that was my inspiration for many of the things that I did, and she also was a person who worked in drug design, was Trudy Elliott. And I was very fortunate to be able to spend a lot of time with her. She was a very down-to-earth person. She came to our research conferences just like everybody else, would go to the Gordon Conference and hang out with everybody, and it was really wonderful. And she took a very personal interest in my career. And Trudy never received, she never earned a doctorate. She got a master's degree, and she worked in George Hitchings' laboratories for years, and you can see him on the bottom. And they were both awarded the Nobel Prize for Medicine in 1988. And when we were back at the University of South Florida, Dean Schneller gave her an honorary doctorate, and I got to spend 3 days as a graduate student driving her around the campus and taking her to all her meetings. And then that was sort of what began the friendship between her and myself. And she followed my career right up until the point that she died a few years ago. And she was really a wonderful woman. Not only did she create all of these drugs that you can see listed there, but she had a great sense of humor. And she'd been through a lot of trials and tribulations. She never married. Actually, she was engaged, and something happened to her fiance, and she never married again, and never took it up or anything like that. But she had a great sense of humor, and she realized that for many years that many other people were getting credit for work that she had done. But one of the best quotes that I found from her was that it's amazing how much you can accomplish when you don't care who gets the credit. And I always thought that was a really great thing, because most people really want that attention. And she didn't care. She just wanted these drugs to be out there. So she didn't care who got the credit for making the drugs. But she's actually responsible for the drugs that you see on that list. And many of them are still used today. Very, very important. And a funny story with Dean Schneller is that early on I said to him, when I started in his group, how do I know if I should go into industry or academia, or, how do I choose? How do I know which way to go? And he just laughed, and he just looked at me and he said, "You'll know." And I remember leaving his office being so frustrated, because I wanted him to tell me, go to industry or go to academia or go to, law or something, and he just wouldn't do it. He just shook his head. Every time I would ask him, what direction should I go? What do you think I'm going to be good at? And he would just laugh, and he'd say, "You'll know." And one day I remember teaching, when I was at University of South Florida, I was a teaching assistant, and I got to do the recitation sections. And I actually subbed for some of the professors when they were, out of town or something. And I remember walking into his office one day after having a really great session with my students, and I saw the light bulbs go on. And it was so exciting. And I walked into his office, and I just looked at him and I said, "I know." And he smiled and he said, "I knew you would." And in that regard, I was honored in 2002, another changing event, with the Georgia Tech Outstanding Teacher of the Year for all of Georgia Tech. And this is as an untenured assistant professor of chemistry and one of the only women in an engineering school. And it was unbelievable. And I got this really nice plaque, you can see there with my youngest daughter, and $10,000 cash. Well, technically not, that was before taxes. Actually, I got about $5,600, which that's one of the reasons you see that really big smile is that check. So that really helped Allie and I out, because at the time she was just about to need a car because she was turning 16, and so part of that money went for her down payment for her car. So she was very excited too. So some of the advantages of getting these awards. And so anyway, as I said, the other thing that happened in 2002 was that I went up to Washington to do study section. And it was, as the Italians call it, the thunderbolt. And here I met this wonderful, wonderful man who actually up until that point I really wasn't that fond of. I was actually sort of mad because they never funded my grants. And so he said, fine, come do study section. And I said, fine, I will. And the first day at study section, I remember someone walking into the room and starting to shake hands, and it was just like kaboom. And I was in love. And a couple months later, we went to Paris. I was giving a lecture at an international meeting in Belgium, and we snuck over to Paris, and he actually asked me to marry him there in Paris, so it was quite romantic. But the very interesting thing about this is that about 8 years before we met, there was actually a romance novel written almost exactly about our story. But I kid you not. And you can see it here on the bottom. And Jennifer Sinclair, for those of you who don't know her, is actually a Gulf Shores, Alabama resident. Her husband was on my husband's study section on traditional medicines. And he was joking around with her, and for those who met my husband last night, you know he's like me, very shy and retiring. And he was teasing her about the fact she wrote romance novels. And he's like, write a romance novel about, scientists. And so she did. And it has to do, and the hero in the story is this Grant. His name is Grant, and he's, some sort of scientific administrator, and this young, beautiful, yeah, young and beautiful, not, but of course gets very angry at him because he doesn't fund her grants, and in the end, of course, typical romance novel, they end up together and live happily ever after. Now, of course, like I said, this was 8 years before we even met, but the funniest thing is she couldn't get anybody to publish it because all of her publishing houses said, scientists aren't sexy. They said, change it to a doctor or a lawyer and then maybe we'll publish it. And she really stuck to it. And actually the book is dedicated to Mike, my husband. And he even drives a red Porsche just like the guy in the book. And so she finally got it published. I think there's only been like 11 copies. And to be honest, no offense to Jennifer, but it's the worst book I've ever read in my life. I have to admit this, and please don't ever tell her, but I think I got through about 3 or 4 pages before I just had to say, I can't do it. But anyway, so that sort of changed, that started the next phase of my life. And at that point, I came back from Paris and suddenly found myself looking for a job in the Washington, D.C. area. And things have a way of happening. And I ended up at the University of Maryland, Baltimore County, and moved my research group up there. And although I have to say the first thing that happened, there was a huge snowstorm in Washington the first year, which almost never happens. And one of my graduate students, who were all from the South or foreign, said, Doc, what is this white stuff? So we had about 2 feet of snow the very first year. So at first they weren't very happy, but they got used to it. So, and then, as I said, I made that trip to Russia, and that was the first of many. And in 2006, I saw a notice for the Jefferson Science Fellowship Program. And this was a program that was started 5 years ago by then Secretary of State Colin Powell. And the idea was to bring a handful of tenured professors to the State Department for a year in various fields of science and technology and mathematics and engineering, and to sort of introduce them to policymakers and to introduce the policymakers to scientists and get them talking and build, this sort of cadre of expertise that they could call on when new things come up. I mean, the idea is, we all know that there's a lot of policy that is made in government that has to do with scientists. But unfortunately, there are almost no scientists that are contributing to those decisions. And so sometimes, no offense to the current administration and previous administrations, but sometimes those decisions are really wrong. And they're not based in scientific fact. And so his idea was to bring scientists together with these policymakers and help them to start to talk to each other so that when something new like stem cell research or nanotechnology or something like that came up, that they could get the proper expertise and advice on those particular issues. And if you think about, and here you can see, this was at the swearing-in ceremony. The guy on with the white hair is George Atkinson. He was Colin Powell's and Dr. Rice's science and technology advisor up until last year when Nina Fedorov took over. And this was the swearing in at the State Department in the Benjamin Franklin room. It was quite elegant. It was really a spectacular ceremony. It was an honor to be part of this. And I was in the third class. The first year there were 5, 1 woman. The second year there were 5, no women. My class there were 6, 1 woman. This past year there have been 8, 2 National Academy members and 1 woman. So far there are 3 of us. We're making headway. Unfortunately, the current class that will start, actually, they started last week. I'm sorry, couldn't remember what date it was. There are no women, unfortunately, this year. But it's one of those things, at least we've had a few, and we're trying to increase the profile of this. And so we hope that we will have many more. And as I've shown here, if you think about it, many of the challenges that face our nation are scientific. I mean, a lot of these issues you see in the newspapers every day. Global warming, stem cell, nanotechnology, HIV/AIDS, all of these issues are things that policy is made on. And so as I got more involved with the Russians on the smallpox projects and then started working on this, and I spent a year at the State Department. That was part of the assignment. First of all, you had to get at least secret security clearance. I ended up with 2 above top secret. So I can't really tell you a lot or I'd have to kill you. But many of the things that we don't realize that the State Department works on, and the State Department also works very closely with other agencies like CDC and HHS, NIH, the Department of Defense, the Department of Energy. Many of the government agencies deal with scientific issues, and so they need input. And I think one of the other things that Colin Powell wanted was not only to introduce scientists to policymakers, but also have the scientists go back to their universities and tell their graduate students and their postdocs, hey, this is a new career pathway. And to be honest, before I got involved with Russia and then with the Jefferson program, it never occurred to me to tell my students that that was a career pathway. I didn't really even know about it. Even though my husband, as a scientist, works for a government agency, it just didn't click in my head that there was a need for this in these agencies in downtown Washington, D.C. And trust me, there's a huge need for it. And so actually 3 of my students are now, well, 2 are pursuing policy careers, and 1 who's about to graduate wants to pursue a policy career. And it's exciting for me to see that that actually is working. And so hopefully many of you will also come away from this today thinking about that possibility as a career pathway as well. And let me tell you, there are many, many opportunities for internships. In fact, we were discussing this at the table with Tina. And there are many possibilities for internships in Washington, D.C. at all of these agencies. For undergraduates, for graduate students, there's many policy fellowships. There was an article about me in Science 2 months ago. And at the very end of that article, there's a whole listing of policy fellowships that are available for various levels of people, and so there's a lot of opportunities. Plus, it's pretty neat to work in Washington, D.C. You know, you're there among all the Capitol buildings and all the monuments, and it really brings it home that, you know, you're in the nation's capital, and that's pretty exciting. And anyway, so one of the things that I worked on at the State Department was bioterrorism. I continued my work with the smallpox projects in Russia, and I also went to, let's see here, I went to Indonesia. And I worked on a project with helping two of the main laboratories in Jakarta and Bogor on developing some BSL-3 laboratory facilities to work with very dangerous pathogens. And we had a very interesting time there. We were there for 2 weeks. I took a team of scientists and engineers over there to work with the Indonesians on helping them. And there you can see the design plans for the BSL-3 facility. And this is the director and co-director of the Institute. And we had just finished 2 very, very intense weeks of working on these plans. And then we had a little bit of time off, and we took the team by boat, a 2-hour boat ride out on to one of the little islands, and got to spend the afternoon lounging on the beach and, you know, getting a tan and enjoying the coral reefs and relaxing before we went back and finished some more work with them. And it was a lot of fun. And in the meantime, you might recognize this person right there, one of my very dear friends who happens to be Indonesian and happened to be in the country at the time, and I didn't know this, so it was very exciting. Nita McKee flew down to meet me, and her sister and her sister's husband, and Nita took some of us all over the town, and we got to do some sightseeing and get some stuff, because technically we weren't supposed to leave the hotel unless we were with the embassy driver, but we snuck out, so we had a great time. And the neat thing was, Nita was wearing her Auburn t-shirt, so we got to do a little war eagle in Indonesia. And one of the other things that was really neat about the time that I spent at State was that I got to see a lot of Dr. Rice, and she is an amazing woman. You want to talk about inspirational. She has accomplished so much, and she's just she's a concert pianist. I mean, she's done so many different things. She's also a Russian expert. That was her area of study, and she's just a really neat woman. And this is her swearing in Dr. Fedorov, who is the new Stas, her new Stas. And Dr. Fedorov's work, she's from Penn State, and her work is in plant technology, in developing new genetically modified foods and things like that. So she's working in a very hot area. Now, obviously, when the new administration comes in, most likely she will return to Penn State, just like Dr. Atkinson went back to Arizona, where he was a chair of the chemistry department there. And so there were a lot of very interesting things that I got to observe and spend time with these people, and that as a normal chemistry professor, I never, 10 years ago would have dreamed that I would have the opportunity to do. And while I was in Russia, I met with many, many high Russian officials, just all the way up to almost Putin, one level below, and I got to do an awful lot of very interesting things with the ambassador of Russia, the ambassador to Russia. And it's been very exciting. And one of the things that happened at the end of my year, when I was supposed to return back to my university, we were supposed to stay involved for the next 5 years. And just before I was ready to go back to the university, the director of the Science and Technology Office in Moscow asked me to come and help out in their office on some special projects, which unfortunately I can't discuss, but it was a very interesting opportunity. So I spent 3 months in Russia last fall, living there at the embassy. And as I say, and actually I just got back from there 3 days ago. So I'm still sort of on Russian time, still sleeping a little bit. But to give you an idea of some of the other things that I've gotten to do. As I said, before 2002, I never left the United States. And here you can see a meeting in Belgium. And these were colleagues of mine. We were enjoying mussels and in Bruges in Belgium and talking science. And Slovenia, I gave a talk at the university in Slovenia. You can see here that the Swiss Alps, and also this is in Bled, and then Piran, which is down on the seacoast, very close to about 10 minutes away from Italy. So I got to go to, and I highly recommend Slovenia. It's one of my favorite countries, really, really neat. And Camerino, Italy. Last summer, I gave a talk in this fortress town from the 1600s. You can see the walled city as we came up the hill towards the town. Their university was started in the 1300s. It's just incredible. And these students are just walking around in this, it's like history. It's like a history lesson. And it was spectacular. It was very beautiful. And my colleague, and also Dean Schneller's colleague that lives there, her husband is decided to retire, and he's now growing truffles. I thought, this is excellent. So we have to go back in about 5 years. It takes about 5 years, apparently, for these things to develop. So that was sort of neat. And then we also went on to Rome, saw a little bit of Rome. I gave a talk at the university there. And then in February, we went to India. I was one of the plenary speakers at a symposium on chemistry biology interface in India. So we went to see the Taj Mahal, and also got an elephant ride and a camel ride, and did all sorts of neat things. But I have to say, and this is one of my graduate students, Naresh. You can see him behind there. Many of these trips, my students have come on as well. And so it's something to keep in mind. You know, this is a great way to see the world. Scientists don't necessarily just stay in the bench. You know, we get out there, we do things, you know. And let me tell you, every trip I go on, there's at least one pair of shoes that comes home, especially from Italy. My husband counts it by the number of shoes. It was a 4-shoe trip. It was a 2-shoe trip. Last month, I went to Germany and Austria to do some work on the smallpox projects as well. And here you can see I'm up on the top of Zugspitze, which is the highest mountain in Germany, and it borders, it splits at the top. Part of it is Austria and part of it is Germany. So if you walk across the outlook thing that they have at the very top of the mountain, and you can either go up by a cog train, or you can go up by the ski lift type things, and those go really fast. Cog train goes very slow. We went up by the ski lift thing and then down by the cog train. It was very interesting, and we had the final banquet there. This was a meeting on pox viruses, and you can see they had all sorts of entertainment, and there we are discussing science at the table, and you can see sort of down the sightseeing. So it was spectacular, a very nice opportunity. Now, as I said, I've spent a lot of time in Russia, and for many different things. I've been there now 11 times. I've had all sorts of great opportunities. On the bottom, last year I gave a talk at the American Center to prospective students who want to come to the United States to study, and so got an awful lot of people emailing me, you know, about coming to the United States to join my research group or to help get into colleges, in other fields, and so that was quite exciting. The little boy on the right is the best friend of my best friend's husband in Russia, and last year while I was living there, I was taking Russian lessons at the embassy, and on Sundays we would do our homework together. He would do his English homework and I would do my Russian homework, and he's about 11, and it was about the same level. So, and let me tell you, it's pretty embarrassing to be corrected by an 11-year-old. So, but we worked pretty hard, and here's some other pictures from different trips to Russia. On the upper right-hand side, you can see another one of my students who is now, former students, who is now working for a defense contractor in Washington, D.C., and doing very well. And this was actually interesting. We went, on one of the trips, we went to Siberia and stood on the continental divide, 1 foot in Europe and 1 foot in Asia. So they also have a continental divide. And this was out in the middle of nowhere. It was about 30 below. We drove an hour and a half in a very, very bumpy truck that had no springs. And so every time we'd hit a bump, I would fly up, my head would hit the roof, and I'd come back down and my butt would hit the springs. And so after an hour and a half out, we got out, we took a couple pictures, got back in, an hour and a half back. It was like, oh, I was never so glad to be out of a van in my life, but it was a great experience. Last summer, I did a scientific conference on a boat. And this was pretty interesting. I'm not so sure how much science actually got accomplished, but it was a lot of fun. We left Moscow and floated up the Volga River for 5 days. And each day, we would stop at a small town and get out and sightsee and meet people and sort of do things like that. And at night, because while this was happening, it was White Nights time, which in Russia, it happens around June 20th, and that's the longest day of the year. And so it only if you look at the lower left-hand picture, this was taken at about 2 o'clock in the morning. It's still daylight. So we would have about maybe an hour of sort of dusk, and then the rest was bright light. So they would be up on the top of the boat doing disco dancing with, and I would just be like, isn't it time to go to bed? I was dying, but they loved it. They loved their disco dancing and music from the 80s, I kid you not. But it was a lot of fun. We had a good time, and I got to see more of Russia. And oh, here we are in native garb. And these are all 3 scientists, and obviously, I showed this to my husband, and he didn't even recognize me. So I thought that was pretty funny. And then we also were lucky, we got to go do some non-touristy things, and we went camping with our friends, and the national sport of Russia is mushroom picking. And so we went mushroom picking, and I let them do the picking because they're the experts, and that's really important. And so just to sort of summarize and give you an idea, since that first trip to Russia in 2002, I've been to 14 different countries, something that I never would have thought I would have done, you know, just as a university professor doing research in drug design. And next week, I leave for Japan and Korea, and I'm giving talks in both those countries. And after that, I'm going to stay home for a while. It's been a lot of travel and very exciting, but it's time to stay home. And fortunately, my husband's gotten to go a little bit with me, so that's helped. But my students miss me. Here's a list of my students, and you can see the ones highlighted in pink here. And as you can see, they're from all over the place. We have a very international group. We have great parties. Everybody brings something from their country, and we have awesome food cook-offs. And they're very competitive. You know, it's like they have to outdo each other as far as their dishes from their countries. And so it's been a lot of fun. And you can see, here's one of my students, Sly Mosley, former students. We went to Barcelona. He took first prize, won $1,000. Did he share it with me? No. And this is after he got the check, and you can see Samir in the background also. So they had a lot of fun in Barcelona. He was also featured in CNE News. I guess that was earlier this year, I think, and because he had an American Chemical Society scholarship, and so I'm very, very proud of him. Another one of my current students was the first Wyeth Graduate Fellowship. Wyeth Pharmaceuticals just 2 years ago signed an agreement with UMBC to support this fellowship, and he was the very first recipient, so I'm also very proud of him. And this is just some pictures of my group at different parties. You can see a lot of smiles. They're pretty happy. We have a pretty good time here. As Dr. Wooten pointed out, I have had an awful lot of undergrads in my group too, so you can see some of the undergrads here. I highly recommend undergrad research for everybody who can do it. As somebody pointed out this morning, it helps you decide not only what you want to do, but what you don't want to do. Because if you try different things, it gives you an opportunity to sort of sample things. And you may think you want to be something or do something, and you get in that lab and you find out what it's really like, and it could be like no, don't want to do that for the rest of my life. And on the other hand, you can get into a lab, start a project, and realize just how exciting it can be, and that spurs you to go on. And I see a much, much higher rate of success with students who've done undergrad research than I do with people coming in to graduate school that have never tried anything. And we've also had 3 high school students work with us, and all 3 of them went on to graduate school and have done very well. So we're very proud of them. And we also go to baseball games. That's really important in my group. We used to be, big Braves fans, but now we have all these teams to choose from in Washington with the Orioles and the Nats, but we're still big Braves fans, as you can tell on the back of slides. We recently went to the Nats-Braves game, and of course we were all in the Braves outfits and sitting amongst all the Nats people. And we won that night like 10-2. It was awesome. And this is the most recent picture of my group at my 50th birthday party in May. So it was great, because even my former student from Notre Dame came. He's doing a postdoc at Notre Dame. It was a big surprise, so that was a lot of fun. So I'd sort of like to just close up a little bit and just say, to repeat some of the things that have been said today. What does it take to be a scientist? Knowledge, obviously. Drive, dedication, an open mind. But what does it take to be an outstanding scientist? Knowledge and curiosity, definitely curiosity. It's one of the things I think that draws us to science, is that curiosity to solve those problems or to find out why. And I think, obviously you can't just have drive, you have to have ambition. What I tell my students, and maybe it's because I've had a non-traditional pathway and I got a late start, if you want to play with the big boys, you got to work hard. And it takes a lot of dedication. It takes sacrifice. As a single parent, it was very hard. There were times when I had to sacrifice, Allie had to sacrifice, but you know what? You get through it and you achieve your goals, and no one can ever take that away from you. And I think that's really important. But you also have to be bold. You also have to have courage. And this is my favorite. You have to be hungry. This was taken in Siena last summer. This graduate student from Spain, I thought this was the perfect picture to sort of end with this. You've got to want it. You have to be hungry. You have to have that drive and that desire to achieve that goal. And like I said, once you achieve it, nobody can ever take it away from you. And so to end, I'd like to say War Eagle. War Eagle. War Eagle. This was taken in Moscow on Sunday, this past Sunday. And like I said, I just landed. I had time to pull the clothes out, send them to the dry cleaners, and pack them again. But in the background on the right, you can see St. Basil's Cathedral, and on the left, you can see the Kremlin. And like I said, this has been an outstanding adventure so far. And I look forward to many more. And I look forward to you guys achieving those same adventures. Thank you for your attention, and thank you for